In many ways, weather is the single most important phenomenon affecting both pilots and air traffic controllers. From light mist or rain that can reduce visibility to thunderstorms that can produce lightning and damaging winds, controllers and pilots must make decisions based on weather conditions that have a huge impact on air safety. One of the most important tools controllers and pilots have for receiving weather and other important information is the ATIS. Hello, my name is Kyle Warner. I'm an air traffic control student at the University of North Dakota here in Grand Forks. We're going to take a look at what goes into an ATIS and how to record one today on ATCast.
Hey, Roger. Thank you. JetBlue 1264 Boston, ground taxi ramp via November and Alpha. Boston Tower, Gulf Stream 717, Echo Pop 30 on the ILS 4 right approach. Hey, there's 741 is checking out. So 741 Boston Tower, good evening. Thanks for calling 737 distance time now. I'm like 4 right for the last, touch push your launch flight 1005. 417, thanks for the service terminates, clock VFR for the change, we'll see you way back. Okay, 117, okay, good night now.
Dan Lindsay is joining me today in our 360-degree tower simulator. Take it away, Dan.
Thanks, Kyle. I'm Dan Lindsay, and in this episode we're going to talk about the ATIS, or Automatic Terminal Information Service. If you've got some flying experience already, you probably know that weather influences almost every decision a pilot makes, from whether to fly at all, to how to fly an approach for landing in a crosswind, or even what altitude to select for the route of flight. But the ATIS doesn't just talk about weather. It also tells pilots what approaches, runways, and frequencies are in use, if there are any NOTAMs for things like runway or taxiway closures, if something unusual is going on like construction work or maintenance, and it provides information on hazards like low-level wind shear and bird or wildlife activity at the airport. We're going to cover three things in today's episode. First, we'll talk about the Aviation Routine Weather Report, also called the METAR. Then we'll talk about the ATIS itself and the phraseology you'll need to know for that. For some of you, this could be your first exposure to FAA phraseology and the requirement to say a specific thing in a specific order. But don't worry, because we're going to have some examples for you to listen to help you get a feel for it. We'll wrap it up by talking about how to record the ATIS in the tower labs here at UND. We'll start off by talking about the METAR. I'm going to use some examples from page 4 of your Tower Lab Simulator guidelines if you want to follow along. The METAR is the primary component of the ATIS. It describes the weather conditions present at a reporting station, which is usually automated, at the time of the weather observation. Like I said before, METARs are produced at least once per hour, usually about 7 to 10 minutes before the top of the hour, but new reports can be generated as often as necessary to reflect changing weather conditions. The METAR contains 9 sections. We'll look at example Kilo from page 4 of the Tower Guidelines packet and highlight each section as we go. The ATIS phraseology is coming up in the next segment, so please note that how I describe things in this segment is not necessarily how you'll read them in an actual ATIS. The first part is the station identifier. In this case, it is Academy Airport, or KAAC. Any reporting station in the continental US is prefixed with a K. Stations in Alaska and Hawaii are prefixed with a P. The next section is the time. The first 2 digits indicate the day of the month on which the observation was taken. In this case, the observation was taken on the 6th day of the month. The last 4 digits show the time of the observation, and the Z indicates the time is shown in Zulu time, 2054 Zulu in this example. METARs and other aviation weather observations are always shown in Zulu time, which is the same thing as Greenwich Mean Time. The third section is winds. The first 3 digits show the compass heading from which the wind is blowing. In this case, the wind is blowing from heading 060. The next 2 digits show the speed of the wind in knots. This example shows the wind blowing at 15 knots. If wind gusts are present, the wind speed will be followed by a G and 2 more numbers. Here we see that winds are gusting to 22 knots. Following the wind is the visibility section. Although most distances in the aviation world are given in nautical miles, visibility values are the exception to the rule. They are given in statute miles, which is indicated by SM after the numbers. This example shows a visibility of 10 statute miles, but the value can be given in either whole miles or fractions of miles as determined by the reporting station. The weather section comes next. This section describes any precipitation or other weather phenomena happening at the time of the observation. Our example is not showing any precipitation, but any number of different types can be shown here, from rain to snow to mist. If you look through the other METAR examples on page 4, you'll see a plus or minus symbol first in many of the weather sections. These symbols refer to the severity of the precipitation. A plus is read as heavy and a minus is read as light. If a plus or minus is not present, the precipitation is considered to be moderate. This episode would be pretty long if I tried to explain every single kind of weather element you might see here, so instead I'll show you the ones you'll probably see most often. TS means thunderstorm. It might be preceded by the plus or minus symbol we talked about a minute ago, but those symbols always refer to the severity of the precipitation and not to the severity of the thunderstorm. Here are the symbols you'll see for rain, snow, mist, and hail. FZ means freezing and can be shown in conjunction with rain or mist like this. SH indicates showers. If you see something like this in a METAR, it is indicating rain showers. You might be wondering, what's the difference between rain and rain showers? Rain is considered to be a period of steady precipitation, while rain showers refer to intermittent periods of precipitation. BL means blowing, and if you see it along with snow, it indicates blowing snow. These are just a few examples of what you might see in this section. For a complete listing, refer to FAA Advisory Circular 00-45F, Aviation Weather Services, which describes all the available aviation weather products and has a lot of nice color pictures and charts detailing the different weather products. It can be downloaded as a PDF file for free from this website. Click on Advisory Circulars in the upper right-hand side of the page, and on the next screen you can click on Search by Number and find 00-45F in the list. You can also go to www.undsatka.org and find the link there as well. Page 3 of your tower packet also lists the different symbols you may encounter. After the weather comes the sky conditions section. This is where cloud types and altitudes are shown. You'll see a grouping of 3 letters followed by 3 numbers. The 3 letters show which type of cloud layers are present, and the 3 numbers show their altitude above ground level. Take note of this fact because it is one of the few instances in the ATC world when an altitude will be given an AGL instead of mean sea level or MSL. The farthest number to the right is hundreds of feet, and the 2 numbers before that are thousands. For example, this would be 300 feet, this would be 3,000 feet, and this would be 30,000 feet. If more than one layer of clouds is present, there will be more than one grouping. Our example shows one layer of few clouds at 4,200. Let's look at some of the information you might see in this section. Either of these 2 descriptors means clear skies. This means few clouds, which is officially defined as 2/8 or less of the sky being obscured by clouds. This descriptor indicates scattered clouds, or 3 to 4/8 of the sky obscured. This is broken clouds, defined as 5 to 7/8 of the sky obscured. The last descriptor means overcast skies, or 8/8 of the sky obscured by clouds. Broken and overcast are considered ceilings, which are important in part for determining if conditions are VFR or IFR. You may also see CB, which means cumulonimbus clouds, or TCU, which indicates towering cumulonimbus clouds. These types of clouds are the most hazardous to pilots. The next section is called the temperature and dew point group. These 2 temperatures are given in degrees Celsius. The first 2 digits show the temperature, followed by a slash, and 2 more numbers which show the dew point. If there is an M before the number, the temperature is below 0, and if there's no M, it's above 0. In our example, the temperature is 25 and the dew point is 13. The next to last section is the altimeter setting, which is provided in inches of mercury. As you may already know, standard sea level pressure is 29.92 inches of mercury. This information is preceded by the letter A and is shown as 4 numbers with no decimal. Assume that the decimal is after the first 2 numbers. Our example shows somewhat high pressure at 30.14 inches of mercury. Pilots use this information to set the altimeter aboard the aircraft. The final section is the remarks. Basically, anything not covered in the standard METAR format is placed in this section. You might see things here like the type of reporting station, variable ceilings, and braking action reports. Let's look at another example from page 4. Oscar is a little more complex. This observation was taken on the 6th day of the month at 2055 Zulu. The wind is out of the west, 260, at 8 knots and is gusting to 17. The visibility is 1/8 of a statute mile, and there is heavy snow showers and blowing snow, or a typical January day in Grand Forks. In this case, there is a ceiling, one of broken clouds at 200 feet AGL, and another layer of overcast at 600 feet AGL. The temperature is -4, and the dew point is also -4. The altimeter is 29.54 inches of mercury. Coming up, we'll look at what goes into an ATIS and the phraseology used to read it.
If the winds are coming from a magnetic heading of 060, which runways would most likely be in use at Academy Airport? Runways 10 right and 10 left would likely be the active runways because aircraft should land and take off into the wind whenever possible. A temperature and dew point that are the same or are nearly the same is conducive to what kind of weather phenomenon? A temperature and dew point that are the same or nearly the same means that the air is saturated and fog will likely develop, creating reductions in visibility.
Now that we've talked about METARs, let's take that and put it together with other airport information and make an ATIS. We'll start with the format of the ATIS and then get into some phraseology. The ATIS is made up of 4 general sections. The first is essentially a reading of the METAR that we just talked about. The second section includes the instrument approaches in use, along with the runways in use for arrivals and departures. The third section provides optional information such as tower and approach frequencies in use, notices to airmen or NOTAMs, and other airfield advisories. The last section includes a very important phrase that we'll get into in a minute. We've already gone over what's included in a METAR, so now let's talk about how to read it on the ATIS broadcast. Yellow text indicates something that must be read exactly as it's shown on the screen. You'll begin every ATIS with the phrase Academy Tower Information and the letter of the information. ATISes begin at letter A and continue all the way to Z, at which point they start over again at A. Next, you'll read the time of the observation. You don't read the day of the month, just the 4-digit time read as single digits and the word Zulu. The wind information is read as wind, and then the direction of the wind is single digits. At, and then the speed of the wind, also is single digits. You do not say knots. If there are wind gusts, you would follow up the wind speed by saying gusts, and the speed of the gusts as single digits. Next comes the visibility. Even though it is given in statute miles, you do not say statute miles or even miles. Just say visibility and give the value in single digits. Fractions are a little different. If you see a value like this, you could read it visibility 1/4, and this would be read visibility 1/8. Now for the weather section. Here you simply read the descriptors as they are listed. Snow, rain, freezing rain, and so on. If there are multiple items, read them in order without and in between. Freezing rain, hail, snow. Remember that if there is a plus or minus, it applies to the precipitation. For example, you would read this as thunderstorm heavy rain, or this would be thunderstorm light rain. Cloud information comes next. You do not say sky conditions, just begin with the altitude followed by the cloud layer. Now there are 2 exceptions to this rule. The first is with few clouds. If this type of layer is reported, say few clouds at, followed by the altitude. If the cloud layer is broken or overcast, say ceiling and then the altitude and cloud layer. For example, if you see this in a METAR, you would say few clouds at 5,000. This would be read ceiling 4,300 broken, 6,700 overcast. There can only be one ceiling, and it is the lowest layer that is reportable as a ceiling. If the METAR reports these 2 symbols, you would simply say sky clear. The only difference between these 2 is that SKC is reported by a weather observer who physically sees clear skies, while CLR is reported by an automated station. If all cloud layers are above 5,000 feet and the visibility is greater than 5 miles, you can omit the visibility and sky conditions and simply say, the weather is better than 5,005. Temperatures are read next. Even though they are given in Celsius, you do not include the word Celsius when you read them. Say temperature, and then the temperature is single digits, followed by dew point, and the dew point read as single digits. If there is an M before the numbers, indicating temperatures below 0, say temperature minus or dew point minus as appropriate. The final part of the METAR to read is the altimeter. Like the other number groupings in the ATIS, it is read as single digits with no point or decimal included. I should point out that it's possible for some information to be missing from the METAR. If this happens, you would say missing in place of that particular item. As an example, let's remove the dew point from our METAR. In this case, you would read temperature 25, dew point missing, and then continue on as normal. Next, we get into runway information. First of all, you read the types of instrument approaches in use. If runways 28 right and 28 left are in use, you would say ILS runway 28 right and 28 left approaches in use. If it's runway 10 right and 10 left, then it would be localizer back course runway 10 right and 10 left approaches in use. We do not use any instrument approaches to runway 16 or 34. After the approach is in use, read which runways are being used for arrivals and departures. Say arriving, followed by the arrival runways, and departing, followed by the departure runways. If the same runways are being used for both arrivals and departures, you can say arriving and departing, and then the runways. Bird activity would be included in this section, along with any NOTAMs affecting operations in the terminal area. After the runway information, some facilities include information like tower and approach frequencies in use, or temporary airport conditions like maintenance or mowing. This section is optional and there isn't any specific phraseology. Just use your best judgment and keep the information as concise as possible. If land and hold short operations are being conducted, you would indicate that in this section by saying land and hold short operations are in effect. Any wind shear or microburst alerts are stated in this section as well. The last section begins with that very important phrase that I mentioned a few minutes ago. All pilots read back all hold short instructions. This is crucial because this is the pilot's indication that he or she understands and will comply with instructions to hold short of a runway or taxiway. This phrase means exactly what it says. Pilots cannot respond with Wilco or Roger or anything else. They must respond with the phrase hold short and read back where they are to hold. If the pilot does not respond this way, you must ask him or her to read back the hold short instructions. Every ATIS ends with the phrase, advise on initial contact you have, and then the letter of the ATIS read phonetically as always. Chances are this is a lot more complex than you thought, but rest assured that if you practice reading the examples in your tower packet, you can get this down in no time. Let's listen to some examples now. You can follow along on page 4 of your tower packet.
Academy Tower Information Tango 2055 Zulu, wind 250 at 15, gust 21, visibility 10, few clouds at 3000, ceiling 8000 broken, temperature 0, dew point -6, altimeter 2983. ILS runway 28 right and 28 left approaches in use, arriving and departing runways 28 right and 28 left, departing runways 16 and 34. VFR aircraft from the north, contact Academy Tower 119.2 and from the south 118.2. Radar service is available, Academy approach 120.2 to the north of Academy Airport and 119.5 to the south. All pilots read back all hold short instructions, advise on initial contact, you have Tango.
Academy Tower Information Oscar 2055 Zulu, wind 260 at 8, gust 17, visibility 1/8, heavy snow showers, blowing snow, ceiling 200 broken, 600 overcast, temperature -4, dew point -4, altimeter 2954. ILS runway 28 right approach in use, arriving and departing runway 28 right and 28 left. All pilots read back all hold short instructions. Advise on initial contact, you have Oscar.
Academy Tower Information Echo 2136 Zulu, wind variable at 5, visibility 1 3/4, rain, mist, ceiling 400 broken, 2800 overcast, temperature 4, dew point 3, altimeter 3007. ILS runways 28 right and 28 left approaches in use, arriving and departing runways 28 right and 28 left, departing runway 34. All pilots read back all hold short instructions, advise on initial contact, you have Echo.
Academy Tower Information India 2053 Zulu, wind 100 at 6, visibility 1 1/2, heavy rain, mist, ceiling 600 broken, 1100 overcast, Temperature 5, dew point 4, altimeter 3004. Localizer, back course runways 10 left and 10 right approaches in use. Arriving runway 10 left, departing runways 10 left and 10 right. All pilots read back all hold short instructions. Advise on initial contact, you have India.
One final note about automated weather reporting stations. These stations report the weather they see on their sensors. Activities such as snow removal can disrupt these sensors and cause them to produce incorrect readings. If you see something on a METAR that differs dramatically from what you see outside, use good judgment and keep pilots informed of the observed conditions. Coming up next, I'll show you how to record an ATIS in the tower labs.
1 nautical mile equals how many statute miles? The answer is D. 1 nautical mile is equal to 1.15 statute miles. What cloud type produces the most hazardous conditions for flying? Cumulonimbus clouds are by far the most hazardous to flying because they may contain very powerful convective currents, hail, and lightning, and they can produce powerful microbursts at the base of the cloud.
Now that you know what goes into an ATIS and how to say it correctly, let's go over how to record one in the tower labs. This procedure is the same regardless of which lab you're working in. If you're working a ground control position, the ATIS is your responsibility and should be the first thing you do at the start of a scenario. You also need to keep track of this while you're working the position because it will likely change. If you see the weather change, you can bet that a new ATIS will appear soon. That being said, the ATIS may change without any visible change in the weather outside, so periodically check the display. Once you notice a change, you should update the recording as soon as possible. So how do you know what the weather is? You can find the information on the weather display. There are 2 in the tower, 1 by each local control position, and both show the same thing. The METAR, along with the assigned letter, wind dials for each runway, notices to airmen or NOTAMs, and other airfield advisories. To begin recording, press the ATIS button on the communications panel and start talking. Do not key your frequency, unless of course you want the pilots to hear you record the ATIS. When you're done, press the ATIS button again. The ATIS frequency will start flashing, indicating that the ATIS is being broadcast continuously on the frequency. You can select the frequency to listen to what you just recorded. If you mess up during the recording, just start over again by pressing the ATIS button once to stop the recording, and a second time to start the recording over. Don't just record the ATIS and stop there. Let your local controllers know that new information is current, and let any aircraft on your frequency know by saying, "Attention all aircraft, Academy Information Romeo is now current," or whatever the current letter is. If you want some additional practice, take your Tower Lab Simulator Guidelines packet and use the example METARs. Read them as if you're actually recording an ATIS. It really does help. Also, don't forget to check out SATCA's site on HTML-EZ for a practice quiz on this material. Back to you, Kyle.
Thanks, Dan. On behalf of UND Air Traffic Control, the Student Air Traffic Controller Association, and the Aerospace Network, I would like to thank you for tuning in. My name is Kyle Warner. Frequency change approved.
For more information on UND Air Traffic Control and to see other videos in this series, visit www.aero.und.edu or search for ATCast on iTunes University.